So we are going to start. It's 4 p.m. Sometimes when I start, I don't watch the screen to know if people are coming to be admitted into the class. Anyway, so I want us to look at how to use Excel to do data summary. But before we do that, do you have any question on what we are doing so far?
Um, I don't think so. I guess my only question is for the homework, I really like to like write it out on paper instead of doing it in like a Word document. And I just wasn't sure if that was like okay that I like drew the graphs on my homework rather than like making a like sheet in Excel.
No, that's okay. You don't have to use Excel. You use Excel because it's easier. But if you it's for you, it's easier to do by hand, then that's fine with me.
Okay, I just wanted to
Provided,
double check.
yeah, that's fine. If provided it gets to me and that I am able to see it. If I have not complained, then it means that it was okay.
Okay.
Mhm. So we want to look at. We will quickly go over chapter 3 and then learn how to do data summary, that is finding the measure of variation and the measure of central tendencies
Okay.
using Excel. Just 1 minute, let me get an Excel open, ready. So chapter 3 is on measure of averages and variation. When we speak of average in statistics, we actually mean the center or the middle, which in many instances could depend on what you are dealing with. In some, in some cases, we will be calling the value that occur the most, which is the mode that it is the center, or the value which is actually at the middle, which we call the median, or mathematically, what we call the arithmetic mean, which is the sum of all the values and divided by the total. We call that the mean. Those are generally the measure of central tendencies that are often used. We also have the mid-range, which is obtained by taking the average of the highest and the lowest data value. So the median is generally obtained by arranging data value in order and identifying the middle. But sometimes when you have an even number of values, you will not have one of the data value as the median, but you will take the average of the values that are at the middle. But when you have an odd number of values, the median is one of the data value. Let's look at this example. The first example, we have 6 values. So we will arrange these values in order, as you see here, and then identify the 2 middle values and take their average. Ellie is trying to get in. Ellie, are you in? For example, if we want to find the middle of, let's say, cost of housing in a city, we may not want to just take the arithmetic average because somebody's house might be very expensive. You can have a house of 60,000, another house of 58,000, and then somebody has a house of 500,000. If you take the arithmetic average, you will not get a right idea of what is the cost of housing in that city. That is where sometimes you may want to decide whether you should use the median as the reference of the middle or the arithmetic average, which is the mean. So median is generally used like in income. We speak of median income, like I spoke of cost of housing, we will speak of the median. We use the mode sometimes because we do not really need the actual arithmetic average, which might never mean anything. For example, if we are speaking about shoe size, if you want to take the average shoe size of ladies, you may not want to take the average, which might give you a number like 7.689, which you can never see any shoe of that type. But you might look at what is the most purchased shoe size of women. And in that case, it is the median. That is the value with the highest frequency. So those are easily identified when we are having a frequency distribution table. So this is another example of data values. We have 5 values here, and we can see that because there are an odd number of value, the middle is at 19. That's the median. We are speaking about the median, the mode, and the mean as measures of centers, measure of the middle. So as I said, the mean is the sum of all the values divided by the number of values that you have. So these are, to graduate, Linda needs at least a B in biology. She did not do very well on her first 3 tests. However, she did well on the last 4. Here are her score. What is her arithmetic mean? That is, compute the mean to determine if Linda's grade will be a B. So what we will do is that we are going to add up values and divide it by the number of tests, which is 7, and get 80. We go back to see that 80 is a B. If you have a question, feel free to interrupt me. Just speak, just as in the classroom, and I will answer your question. So the mean is represented by X bar for the sample and by mu for the population. Actually, a measure, as we learn in chapter 1 from a sample, is called a statistic. So the sample statistic for the mean is X bar, and for the population is the Greek letter mu. But the formula remains the same. Sometimes we actually want to use the mean, but because some data values have what we call outliers, these are values that are extremely large or extremely small compared to other data values, we will trim the mean, the data value. We trim the data value, meaning that we cut a little to the right and a little to the left. To trim values, you can take 5% up, 5% down to make sure that you are dealing with the middle bunch of values that will make sense for your data. So that is what we call a 5% trimmed mean. I will explain again that how do you do that? For example, if you have 30 values and you want to trim the 30 values, you multiply 30 by 0.05 and you will get 1.5. You round it up to 2 and you will remove the first 2 and the last 2 values. If you have 20 values and you want to trim the 5%, you multiply 20 by 5 and divide by 100. That's what I say, multiplying by 0.05. And then you will get 1. That means you will remove the lowest data value and the highest data value. And the remaining, let's say if you had 20 values, the remaining 18 values, when you compute it mean, it will be called the 5% trimmed mean. You can also do 10% trimmed mean if you have a very large set of data values. When you do 5% trimmed mean, it means what you are left with is 90% because you took 5% below and 5% above. So when we have data values, we can use it on a classical distribution. The classical distributions are the symmetric distribution that are skewed to the left and skewed to the right. For distribution that are symmetric, the mean, the median, and the mode are all the same. It's exactly the same value. If a distribution does not have that property, we will say that it is not symmetric. In a distribution that is skewed to the left, the mode is to the right. Because it's skewed to the left, the mode is to the right. So the mode is the highest. The median is always at the middle. So the mean is the smallest. If the distribution is skewed to the right, then most values are to the left. That means the mode is to the left. It means it's smaller than the median and the mean. Sometimes in a quiz, you might be asked in a skewed, if a distribution is skewed to the left, which of the following is true? You will have to remember how what are the position of those central tendencies. So we can also speak about weighted average. In this case, we have data values that have weight. When data values have weight, you multiply each value by its weight and then divide by the sum of the weight. Let's see if we have an example. This is an example. Suppose your midterm score is 83 and your final exam is 95. Using a weight of 40% for the midterm and 60% for the final, if the minimum average for an A is 90, will you earn an A? So we have two tests here with different weight. How do we find the average? We will multiply each test score by the weight and then add them and divide by the total weight. In this case, the weight are 0.4 and 0.6, the total is 1. And we multiply 0.4 by 83 and 0.6 by 95, and we get a 90.2 as the average. In some cases, for example, you may want to compute your cumulative grade point average or your grade point average. In computing the grade point average, the weight for each of your course is the number of credit for that course. And you multiply each score by the number of credit, add them up and divide by the total number of credit. This is another application of the weighted mean. So as I told you at the beginning, the mid-range is the average of the lowest and highest data value. So which is, in this case, we have the lowest data value is 2, the highest data value is 7. So the mid-range is 9/2, which is 4.5. Measure of variation. I am quickly going over everything, then we will learn how to use Excel to compute those values. When you only have few values, you can just add them up using your calculator. Measure of variations. There are 3 types of measure. We have the variance, the standard deviation, and the range. We also speak of the interquartile range that we are going to look at in the next section. So the variance is used to determine the variability of a distribution. 2 distributions can have the same mean. If they vary differently, it will mean that the values could change in a different way. For example, if you want to invest your money in a stock, you might get a stock that is the same. Maybe stock A is the same as stock B. But if stock B varies more than stock A, it will mean that today you can be making a high profit in stock B and tomorrow you have a very low profit. So variation is helping you to determine how changes are occurring in the variables. So standard deviation is used, for example, to assess if there is actual difference, if the difference occurs much frequently. So to compute the variance for sample, you take the sum of the deviation, the square of the deviation, subtract the mean from each value, square it, add it up, and divide by n-1. That is the formula for the variance. The standard deviation is the square root of the variance. But for population, you divide by the population size, so you don't do n-1 for the population. So you can go over this PowerPoint to look at the examples that we have there. So as you can see here, the population variance is denoted by sigma square. And the difference with the sample variance is that it is divided by n rather than n minus 1. And the standard deviation is the square root of the variance. The coefficient of variation, because sometimes two distribution may not have the same nature. A distribution might have very large unit. For example, if a distribution is going in a unit of 1 and another one is going in a unit of 100, naturally the standard deviation of the one that goes in 100 will be higher than the standard deviation of the one going with 1 by 1. So to resolve this issue, we use the coefficient of variation, which is simply dividing the standard deviation by the mean. So the coefficient of variation is used to compare variation of data values of this different nature. So the coefficient of variation is standard deviation divided by mean and put it in percentage. Chebyshev's theorem, you will have some questions about Chebyshev's theorem, and I want to spend a little time to explain what it is, because sometimes it looks confusing, but it is not that difficult. So when we have the standard deviation, it becomes the unit of measurement of our distribution. So if we have a distribution, we'll be speaking in terms of this value is 2 standard deviation away from the mean, or 1.5 standard deviation away from the mean. It could be away to the left or to the right. So let me, for 1 minute, change the screen and then explain. I will take a whiteboard here. So suppose we have a standard deviation of 2 and a mean of, let's say, a mean of 4. Then I will use a line and put the mean at the middle. So if you go 1 standard deviation above the mean, you will be at 6. If you are 2 standard deviation above the mean, you will be at 8. That means 2 times 2 plus the mean. In this case, let me erase this mean. Let me make it 5, because let's make the mean 5. I don't want it to look like, because it looks like it is addition of 4. So I have a mean of 5 and a standard deviation of 2. If I go 1 standard deviation above the mean, I will be at 7. If I go 2 standard deviation above the mean, I will be at 9. If I go 3 standard deviation above the mean, I will be at 11. Now, if I go 2 standard deviation below the mean,
How many freaking hours were we doing that?
I will be at 3. If I go 2 standard deviation below the mean, I will do 5 minus 4, which is 1. If I go 3 standard deviation below the mean, I will go 5 minus 3 times 2, which is 5 minus 6, minus 1, and so on. So if I say we are within 2 standard deviation from the mean, it will mean we are moving from 1 to 9. 2 standard deviation, it will be from 1 to 9. So sometimes we want to know what proportion of
Have a
values.
nice night.
Any
See you
question?
tomorrow. Yeah, I'll be here probably like by 9 because I don't need to be here that early.
So if we want to know what proportion of values are within
Because I got so tired. I went to bed at
2 standard deviation from the mean, we are going to count the number of data values that are between 1 and 9 and divide it by the total to know the proportion of values that are within 2 standard deviation from the mean.
See you tomorrow. Thanks.
So generally, the Chebyshev theorem give us the minimum proportion of values that are within k standard deviation from the mean when k is a number bigger than 1. So we will say that within k standard deviation from the mean, within k standard deviation from the mean, there are at least 1 minus 1 over k squared. I will go back to the PowerPoint. So for any data set and for any constant k greater than 1, the proportion of data that must lie within k standard deviation on either side of the mean is at least 1 minus 1 over k squared. So you want to remember that if you want to be within 2 standard deviation, k is 2, k squared is 4, 1 over 4 is 0.25, 1 minus 0.25 is 75%. So at least 75% of data values are within 2 standard deviation from the mean. We will do the same procedure to get that at least 88.9% of values are within 3 standard deviation from the mean, and at least 93.8% of data are within 4 standard deviation from the mean. So let's look at this example. A survey of local companies found that the mean amount of travel allowance for executive was 0.25 per mile. The standard deviation was 0.02. Using Chebyshev theorem, find the minimum percentage of data values that will fall between 0.2 and 0.3. And so what we are going to do is that we are going to find the value of k that correspond to that distance away from the mean. From 0.2 to 0.3, we will do, the mean is 0.25. So 0.2 minus 0.25 divided by the standard deviation give us the number of standard deviation we are above the mean. Remember, the mean is 0.25. If the upper value is 0.3, then you are to find the number of standard deviation you move above the mean, divide the difference between the mean and the upper value by the standard deviation. We get 2.5. If we do the same with the lower value, which is 0.2, what is the number of standard deviation we are away from 0.25 to get to 0.2? We will get 2.5. So k is 2.5. And now we recall that according to the Chebyshev theorem, at least 1 minus 1 over k squared percentage of values are within 2.5 or k standard deviation. So, and then we do 1 minus 1 over k squared will be 0.84. So at least 84% of data values are between 0.2 and 0.3. Remember that we are speaking here about the minimum. So we could find by practically, if we go and count, we could get 95% of value. It will still be consistent with the Chebyshev. The Chebyshev is giving us the minimum proportion of values that are within k standard deviations from the mean. So 3.3 percentiles and box and whisk couplers. Percentiles are used to divide data into 100 equals part, but we are generally interested in some positions of the distribution. For example, the 50th percentile is the middle, which is the median. We are also interested on the first quartile, the second quartile, and the third quartile. The second quartile is the median, that is the 50th percentile. The first quartile is the 25th percentile, and the third quartile is the 75th percentile. So generally, what I advise students to do to understand the meaning of quartiles is that the second quartile will divide the data into two equal parts. So you will have the lower part of the data and the upper part of the data. So if you take the lower part now and find the median of the lower part, you get the lower median, which is the first quartile. And if you take the upper part and take the median of the upper part, you get the upper median, which is the 75th percentile. Now, the difference between the 75th and the 25th percentiles is what we call the interquartile range. This interquartile range is another measure of variation. It is also useful to determine outliers of distributions. So this is an example of data values. We can arrange them in order, as I did here, and find the first quartile. The second quartile is 4. So 4 here is at the middle. Then I look at below, and I will identify that the number which is at the middle is 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. If we have 15 values, then the median is 15 plus 1 divided by 2, which is the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So this is the median. The last 4 is the median. Now we look at the values that are below, because this is the 8 values. We have 7 values above, and of these 7 values, the middle is 5 here, which is the upper median, which is the 75th percentile. And below, we have 8 values. I'm sorry, we have 7 values, and the median is the 4th value. 1, 2, 3, 4. The lower median is 3. So Q1 is 3. So the interquartile range is Q3 minus Q1, which is 5 minus 3, equals to 2. So we may now want to discuss the use of the interquartile range to find outliers. So interquartile range take like the bunch middle between the first and the third quartile. So in order to determine the lower outlier, we subtract one interquartile range from Q1 and another half of it. So Q1 minus 1.5 interquartile range will take us right below the data. And if there is any value below that value, it will be a lower outlier. We do the same for Q3, and we move from Q3 1.5 of the interquartile range. That takes us really above, and if there is any value above the value that we get by adding 1.5 interquartile range to Q3, we call that value an upper outlier. So the box and whisker plot is used to represent what we call the 5-number summary of a data set. Those 5-number summary, we have already learned how to get them, is the lowest data value, Q1, the median, Q3, and the highest data value. Those values are called the 5-number summary, which are in turn used to make a box plot. If you look at the box plot here, we start with the lowest data value, then Q1, Q2, and Q3. This box that includes Q1, Q2, and Q3 is called the box and whisker plot. So because we are looking at this box, I want to explain again what we refer to as outliers. You see the distance from the bottom to the top of the box. If we move below Q1 by that distance and add half of it again, anything below where we are will be an outlier. Or we start from Q3, add the distance of the box, add another half of it. If we find anything above, we know that is a loose value, is an upper outlier. So you can also use Excel to make a box and whisker plot. You will need it for I don't know whether you need it. If you choose to make a box and whisker plot for your quiz, you can use, for your project, you can use Excel to do that. Also for your project, some of you might decide to do it manually. It is okay. But if you want to use Excel, we are going to learn how to use Excel just soon. Okay, so we are done here with chapter 3. And I want us to use Excel. Let's look at this example 10. I want to use my textbook to get the data, the values. So in example 10, I hope it's the same as what we have in the book in chapter 3. I just picked this one at random. No, I don't have the data value here. Do you guys have your textbook with you? Do you have your textbook nearby?
I do not.
Okay. So can you look at the PowerPoint? I will take a data set from the PowerPoint then. Do you guys have TI-83 calculator? Do you have the calculator, the TI-83 calculator? Olivia, do you have the calculator? Hello?
I do not have that with me either.
Ellie, do you have? Okay, if you don't have calculator, do you have your laptop?
Yes.
So we can use Excel. So I'm going to share my computer and I'm going to take, I want to pick an example from the PowerPoint. So that we have the data that I'm working on. This data is from example 6 in your textbook. The values are 2, 3, 3, 8, 10, 10. Can you all see those values?
Yes.
Okay, now I'm going to share my, if you don't have this data value, just copy it so that, but I have it, I'm going to type it on my Excel anyway. So I'm going to go to Excel here. So I'm going to type the values. Generally, you are going to have like 30 values, 50 values, 1,000 values. I'm using just this simple one so that we quickly go over it. So I will type 2, 3, 3, 8, 10, 10. These are our data values. So you type your data value on Excel, and then you go to data, then data analysis. I want to make, do you all have data analysis? When you click on data, do you see data analysis? I have data analysis at the top right corner of Excel sheet. Do you have data analysis?
Yes.
Okay. If you have data analysis, you click on descriptive statistics. descriptive statistic, then OK. So on the input range, highlight your data values, A1 to A6. These are our data values. I will want my values to be on the same sheet. So I will make sure I click here and put maybe C3. So this is what you will be doing on your project. You will collect data. For your project, you collect data. To get point for data collection, you have to list those data on your project. You start with telling me what values you have, list all the raw value, and then continue with arranging it in a frequency distribution table with all the questions that I have. Because when you just give me a frequency distribution table, you don't have the point for data collection. Okay, C3 here. Then I will click here, data summary, summary statistics. Do you see summary statistics? On the Excel box, you will see summary statistics. Do you see summary statistics?
Yes.
Okay, then you click OK. So then we have the mean is 6. The standard deviation is 1.53. If you have to round up, always round up to at least one more decimal than the nature of your data values. So when we have here whole numbers, so we can round it, we can say 1.5. But generally, I would prefer that you say 1.52 or 1.53. That is the standard deviation. Round up the standard deviation, I will say, generally, it is assumed that you can round it up to the next I'm sorry, this is standard error, not standard deviation. Standard deviation is here. So let me explain how you will do this with a calculator. For those who are going to follow us later, with calculator, you go to, on your TI-83 calculator, you go to start, then edit, and enter the data values in L1. To enter data value, you key in 2 and press enter. Then 3, enter, then 3, enter, then 8, then 10, and 10. From your calculator, you can enter your data value in L1, then you click Start, go to Calc, and then press 1 for one variable statistic, and then press Enter again, and you will have the data summary. So as we said, for your calculator, you are going to have, that's why I went to calculator, you are going to have the sample standard deviation, and then the sample and the population standard deviation. You will have the sample standard deviation and the sample variance, but you are not going to have the, I'm sorry, you will have the sample standard deviation and the population standard deviation on your calculator. You will know the difference because sample is S and population is sigma. On Excel, you will have the sample standard deviation and the sample variance. Excel does not give you the population standard deviation. Your calculator will give you, so if you are using your calculator, be careful. Don't copy the population standard deviation in place of the sample standard deviation. So if you are using your calculator and I ask you for the variance, you will have to square the standard deviation that you have. If you are using Excel and I ask you for the population standard deviation, I usually don't ask population standard deviation, because as we are going to learn soon in chapter 7, the population parameter is generally what we want to estimate using the sample statistic. So from Excel, you have the mean is 6. Forget about standard error. We will learn that in chapter 6. The median is 5.5. The mode is 3. The standard deviation is 3.742. You can round it up to 3.742. The sample variance is 14. So the kurtosis and the skewness are some coefficients that are generally used to determine if a distribution is symmetrical or not. The range, yes, the range is another measure. It's the measure of variation. It's just the difference between the highest and the lowest data value. The lowest data value here is 2. The maximum, the highest is 10. So this is how you use Excel to do to compute measure of central tendencies and measure of variation. From your calculator, for those who have calculator, you will have the 5-number summary as well. You will see the minimum, Q1, the median, and Q3 on your calculator. So now let's speak about your project. For the remaining 5 to 10 minutes, I will discuss what you are supposed to do on your project, which you already have. Actually, you can always look at it on Canvas. Are you guys okay with using Excel? You can always come back to this recording if you forget. I want to change to go to the project. So, in a group of 2 to 4 students, you want to choose a topic of research. So you might want to decide of whatever you want to do. Don't use this one, but you might want to know how long students are sleeping every night or teenagers sleep a night. So you collect at least 30 data, and you might collect 50, but at least 30, and organize the data into, to get point for collecting data, you have to tell me what is the information you are getting, what is your variable, and list all the variable that you collected, the raw variable. Then group these values into 5 classes, or between 5 and 6, you choose. You can make 5, 6, 7, or 8, but not less than 5 or not more than 8. So you will compute the width. So you will give me the width of your classes and present a table that will reflect your class limit, class boundary, class midpoint, the frequency, and the cumulative frequency. Although I have not mentioned, organize data into a number of 5 classes. So present the data using statistical graph of your choice. So you can use either the histogram or the frequency polygon or the ogive. I will advise that you use histogram, is the one that we have done here. We use the ogive, but histogram is most appropriate. Then write a brief report of your project indicating, or use Excel to present a statistical summary of your data. You will be in a group of 2 to 4. At least one of you should be able to do what we have just done with Excel to get a report. You copy that report and paste it on your project. Then you write a brief report that will be about maybe half of a page. You don't need to write a lot. Why did you choose the topic you choose? I want to see that. Who did what on your project? You are for. How did you organize yourself in doing the work? What have you learned from the project? So if you are in a group of 4, you should collect 40 data values. So you may decide to go online and look for data. When you are collecting your data online, that you are getting to the choice B, meaning because you are just getting those data online, you are not doing much work. You can even have 100 or 1,000 values. Generally, you can go online. There are some bank data that have a lot of information, and you can collect at least 50 values. So once you have those values, you can use a graph to make either a histogram of a time series graph. If your data occur over a series of time, you can make a time series graph. Then use Excel to get, because your data size is large, you can't compute it manually. Use Excel to make a statistical report. That is that summary. Please, data summary is not summarizing your data, your research. Data summary is what is the mode, the mean, the median, and all of those information that we learn in chapter 3. That is what I generally call data summary. Summarize your data, and now for all of you, you should be able, I mean, if you take a large number of data, like let's say more than 50, you will not need to group it. This is B. Look at, I have A and I have B. So when you have a large number of data, you may want to do this type of work. What proportion of values are within 2 standard deviation from the mean? And you will tell me, is it consistent with the Chebyshev theorem? This is replacing the fact that you are grouping your data into 5 classes. If you are very large, it will be a lot of work for you to do to group them. Some data are up to 1,000, but once you use Excel to summarize it, you will be able to find the mean, the median, the mode, and the variance and standard deviation. So you can get if you have the standard deviation and the mean, it can be used to find the coefficient of variation. It can be used to determine the proportion of values that are within 2 standard deviation. This is not what you have on Chebyshev. When I ask you, is it consistent with Chebyshev? What you are going to do is that you determine, this is for those who will choose the B project. In the B project, you collect your data online, you find a summary, and then you determine within 2 standard deviation. For example, your data will move maybe from 20 to 178. You will find a mean, maybe the mean is 60 and the standard deviation is 5. So within 2 standard deviation, if the mean is 60 and with a standard deviation of 5, the 2 standard deviation will be between 50 and 70. And you will literally count how many data values are between 50 and 70 to determine the proportion of values that are within 2 standard deviation from the mean. When you get that, you compare it with the Chebyshev that tells you that it must be at least 75. And you will tell me whether what you have from your data set is consistent with the Chebyshev. So you have 2 projects to choose from. Either you do A or you do B. I am giving B option because you are at home and we are doing this class online. So you can manipulate technology to get data. If you look for data bank, there are many sources of data bank. If you need one, you can just check online, check a newspaper or anywhere. Okay. Any question so far? This is the rubric for the project. Data collection, 0.5. You get marked for data collection if you can see the data you have. If you choose project B, you will provide me with the link of the data. Just provide the link. You know how to get the link, because if you have 1,000 values, I'm not expecting you to type 1,000 value for me. You will just produce the link if you got your data online from a data set, from a data bank. Then organize the data. This organizing data, I know some of you might not do it, but if you are doing project 2, organizing data, I will use the quotient on the Chebyshev inequality to represent that. And presenting it using a graph, you need to do an appropriate graph. If you are organizing your data, if you have collected data and you are organizing it, I say between 5 and 8 classes. I want to see the class limit, the class boundaries, the class midpoint, the frequency, the cumulative frequency, the relative frequency. And then summarizing data. I want to remind you again that summarizing data means give us the numbers that describe the data, the mean, the mode, the median, the standard deviation, the variance. If you like, you add the coefficient of variation. And then your project report. Any question so far? So I am good. If you have a question, let me know. And always remember to send me an email if there is any confusion, either when you are doing your homework or quiz. I will check. It's sometimes not always possible to write everything with no mistakes. So sometimes if you are confused, send me an email. I will get back to you. Any question, Ellie, Olivia?
Nope.
Okay, thank you for participating. As I told you, I have recorded this and I will put it on Canvas, and you can always go back to it if you forget some aspect of it. So thank you and have a good evening.
Thank you. You too.
Thank you.
Thank you.
You're welcome, Ellie.